All right, so welcome everyone to the Torch-MLIR community meeting for the month of October. This is the agenda for today. We're going to go over some changes to our meeting schedule. Then we'll have some workload updates of the different models that have been able to been run by, on Torch-MLIR by Nod. And then lastly, we'll have Stella tell us a little bit about the Shark-Turbine project, which is a project trying to have really nice Torch Dynamo support using Torch-MLIR as well. So first, the updates to the community meetings. So before, we always had the community meetings and developer hours every Monday at 9 a.m. Pacific time. In order to accommodate for different time zones and different schedules for people, we're also having now a meeting at 5 p.m. Pacific time on the second and fourth Monday of the month. And so the first Monday and the third Monday will still be at 9 a.m., but the second and fourth will now be at 5 p.m. And in order to make it very simple for people to keep track of this, there's a calendar that you can add to your calendar. And that will keep track of the office hours, developer hour, community hour, everything will be there, so that you know what links to use. As usual, we have a Discord. So if you want to stay up to date with the latest changes in Torch-MLIR, you should join that. And we also have an LLVM discourse. And with that, before we get to the workload updates, these are some of the commit statistics. We had a lot of contributions in the last 2 months. So thank you everyone who has been contributing to Torch-MLIR. And now for some workload updates. I don't see Anush on the call, but Vivek, are you?
I will give an update on that.
Awesome.
Yeah. So hi all. So for the workload updates, right now we are getting the Llama 2 running with turbine. So Stella will talk in detail about the Shark-Turbine. It's kind of stuff similar to Shark, but she will go into more detail. The other model is that Falcon 180B. That's a giant model that we are able to support with the Torch-MLIR. But right now, due to the memory limitations, we have it on the CPU. For the GPU, we will get that running once we add the sharded support. Apart from the Falcon 180B, we are also able to support the GPTQ model. So earlier, the quantized model were supported via the Bravitas library, but right now we are able to support the GPTQ native GPTQ models through the Torch-MLIR. So the Falcon 7B is right now working end to end with the GPTQ variant. For the 180B Falcon, that is a work in progress, and we hope to get it soon. So that's the set of models, the new set of models that we have now.
So this is a different form of quantization than what Bravitas is doing?
So the way Bravitas is doing is like from the Bravitas path, we need to go through the custom op thing, that we insert some custom ops and then we add the lowering in Torch-MLIR for those specific custom ops. But with this GPTQ part, we don't have any such custom ops. All are the native Torch ops that are there in the model graph, and they are being lowered through the Torch-MLIR path. So that doesn't need any fancy playing with the ops and the lowering in Torch-MLIR for the GPTQ models. And the another thing is that the GPTQ already has support a large number of models, the quantized one. So we have all the models available and we can just lower it via Torch-MLIR.
That's pretty cool. Nice.
Yeah. So any questions? If like. So.
Cool. Yeah, well, thank you so much for the updates. I will now hand it over to Stella to tell us a little bit about Shark-Turbine.
Sorry, of course, the first thing I tried to say, I coughed. Morning, everyone. Apologies for the wall of text. Ramiro reminded me last night that I owed him some slides, so I wrote quickly and then went to bed. People have been asking what's going on the turbine project, so I thought I'd give a quick update. We're not really at a point of conclusion yet where, this is ready to share. So consider this just a preview, basically, of work in progress. Basically, we started as a pipe cleaning of PyTorch 2 experiences. I had some design goals on it where I basically wanted to link in the C++, Torch-MLIR code into a compiler, not pull the rest of the stuff with it, not pull the Python, and just have a pure Python interface from the from PyTorch's Python to MLIR's Python API. And I had a couple of design goals, and that one is I wanted to get rid of the old Torch script module importer that's in there. There's various reasons for that. The one that was pushing us the most was that we needed a lot more flexible management of constants and globals, and that's pretty hard coded in the module importer, and I didn't want to mess with legacy code. And I wrote that, so I figure I can call it legacy code. But the and then that would also sever the C++ dependency on PyTorch entirely, which adds a lot of complexity to these projects. As we watch how we're always bumping the stuff, and it adds a lot of weirdness. So was trying that. The other main motivator was that Dynamo's export path wraps up really nicely the dynamic shape support, which you can piece together yourself with proxy tensor and do a bunch of other things. But Dynamo export gives it to you all in one spot, in PyTorch, and gives you all of that. And so we wanted that because we needed some more control over the constraints of if we had multiple dynamic shaped inputs coming in. We wanted to be able to constrain them and dimensions that were known the same and whatnot. And then we also wanted to rely on Dynamo's strong invariance that it produces for its dynamism. Basically, Dynamo will run a solver and verify that the shapes are not ambiguous with respect to broadcasting, which is a major point of pain in the various compilers. So wanted all of that, and basically just set out to see if that, this was all convergent with the long-term plan that Sean published and whatnot, but wanted to see how far are we, and that's where code started to get written for this. We may or may not use Turbine as a standalone project or brand. It's mainly just a place to write new pure Python stuff and then evaluate it and see where it can go without getting entangled. Let's see. So what is it? The biggest thing that we had a few people working on for a couple months was the importer, which is certainly very similar to Torch-MLIR's importer. For the record, I started as a complete rewrite, and then I think it started swapping DNA at some point. So these should be considered roots of the same tree at this point. I'm not sure who wrote that. Ramiro, did you write that? Or?
So that was partly written by Sean, partly written by Max, who at the time was at Nod.
Okay. So all in the family, but for the record, it started as a complete rewrite, and then because there were reasons, but then as these things go, it probably looks somewhat similar now. The main functional features that it has differentiating it are it has some pluggability with respect to globals and constants that we use in order to set some more policy on that. It supports cements and symbolic ints has come down through the proxy tensor and Dynamo path, and has had the usual level of beating it into submission by people running it through workloads and whatnot with those things. So at this point, I would probably look at it as the successor to the Torch-MLIR importer that we may want to adopt at some point. And then other stuff, again, we were just looking to see how far we could push the pure Python land. Built a tensor implementation on Erie's Python API, that does explicit memory movement, scheduling, async execution, and this was nice to see because it gives us a pure Python eager path that is also good. So it is giving a level of pipeline control that you could usually only get in C++. There's a relatively big chunk of code, the AOT toolkit. I don't have a better name for this. It's just in the turbine.aot package. This is effectively what this replaces the module importer. Effectively, it lets you assemble entire modules, piece by piece, manage the globals, manage the state, drop out to IR emission if you need it. It's kind of an advanced API, but inspired and modeled after what Erie Jax does. So that uses the importer, but then adds a lot of other stuff to it that lets us construct programs in bizarre ways. And then there's the beginnings of just some sketches on some PyTorch-esque kernel development stuff inspired by Palace and Triton. That seemed like a nice thing to try. So what's next? We're really heads down focused on getting all the Hugging Face llama models and related models through with dynamic shapes, exported efficiently with state management that works well with the device and all that stuff. And we'll keep on that probably for the next couple of days. We thought we were there on Friday, and then some issues popped up. And then we'll switch to joining with the work that Vivek's been doing on using different quantizers like GPTQ, making sure that flows through well. And then in probably not this month, but we should have a community conversation about what we want to do with this project. We're probably due for a rebase, that gets us onto PyTorch 2 solidly. There's certainly things in here that can be upstreamed into the current Torch-MLIR construct, but we may want to change the construct, rethink our testing philosophy and all that stuff. I think that that PyTorch 2 could give us a lot of chance to cut some legacy and some stuff that's been holding us back, and hopefully align closer with what's happening elsewhere and make us have to manage less. And we should talk about that once we get some of the stuff landed. And I think that's what I had.
Yeah, thank you so much. Yeah, this would simplify things heavily. So I think at the moment, the Shark-Turbine, with Erie, is only really using the decomposed complex ops paths before getting to the backend contract. And so basically everything before that, the maximize value semantics, refine types, and all these things could be, thrown out or set as legacy code, which would simplify things immensely. Yeah.
Yeah. Again, this is infrastructure people are using, so we're not going to make sudden moves or whatnot. That's why we were sort of doing the sprint on the side. But yeah, I agree. I don't know what the right answer is as to whether we want to maintain a PyTorch 1 fork with everything, or whether we want to maybe extract out the core dialects into a more standalone thing, and then keep all the PyTorch 1 machinery around it. I don't know. I think our interests are to drive as quickly towards the future as possible, but we don't want to leave anyone behind.
I did have a question about how you're handling model parameters. I think we talked about this briefly on Discord, but so my understanding is if you use Torch Dynamo the way that it's normally used, where it's just compiling the moment that you're running the program, it will create graphs that have sometimes 10, 20, 50 parameters where inputs where all the inputs are the model parameters, the different weights and so on. And then Torch Dynamo takes care of handing you the right tensor at the right time. But when you're exporting I'm guessing you want your graph to just be, the forward method that you wrote that has just, the inputs that you have in Python and all the weights and all of that. How does that get glued in?
So if it's probably worth, and maybe the PyTorch folks will document this some more soon, or I imagine they probably have announcements and talks coming up, which is maybe why it's not been talked about as much. But there's Dynamo has two paths out. One that, other than there's always the assemble it yourself out of FX goo path you can do if you like pain. But there's the torch.compile path, which is what we just call eager mode. This is exactly what you described. And then there's the torch.export path, which is more for full graphs, and those diverge in a lot of the details. They're built on some of the same infra, but the torch.export path doesn't functionalize parameters. It's basically just trying to produce one graph with as big of a scope as possible, and then it's capturing the parameters. So what we do is we then have a programming model where before, as we're preparing for export, we set it up so that we can export multiple functions. We can JIT them with different parameters and pass constraints and stuff, and then as we're setting that up, we say, please export and make public these parameters from this NN module, and then that sets up a weak map or a weak dict that similar to what the module importer did, and does the accounting, and then it in our implementation turns all of those into globals that are managed at the module level. And instead of embedding them as arith constants, and so that gives us some more powers to play. Again, Erie has a lot of capabilities on globals for optimizing this that we're exploiting, but that's the basic idea. So Torch export gets you almost all the way there. It basically gets you to the point where it puts a tensor on the FX module, or the graph module that you get back from FX, of underscore constant 35, and that is the same tensor that is in your NN module, and then you just have to handle that. Gotcha. So the default importer without more hooks just emits a constant, and then what we do is we emit globals instead if they've got names applied to them.
Gotcha. Yeah, because I've been playing around with running just regular Llama through Torch-MLIR and Erie, and it's just the IR is like 27 gigabytes, and because all the weights are being inlined into the forward method in my approach, and so it's a big pain in the neck.
Yeah, we've got one. So the link that I had on the current snapshot, I think, has still got one weight. I think it's from a buffer that we're not capturing, that's being converted into a constant, but the rest are all just globals and IR. So that one is half a gigabyte because of that one thing, but it's we'll get all that out of there, and then that's using another Erie feature that's under development, where we're trying to we don't need to emit the values for the constants at all. We can still mark them as global constants, but then we can provide a module that gets loaded first that can source them from checkpoints and do other things. So and the way that's set up is it can still apply constant optimizations and whatnot to those without actually having access to the constant data. And we think that was one of the motivations for this entire project, was to better deal with large constants in these inference models, and fix it so that the compiler can reason about them without actually seeing the contents.
Yeah. Yeah, no, it's going to be really, really useful for large models. Yeah, I do. So I think for now, the dynamic shape support the goal is really to just have it working, but I think something cool that one can eventually do, because PyTorch keeps track of this dimension size here corresponds to the size of this tensor here. Something we struggle a lot with in
Did I lose everyone, or did I just lose Ramiro?
I don't know if you can hear me.
Oh, I think I didn't know if I lost, if I dropped off or if you did.
Okay, I can repeat. So something we struggle a lot in Torch-MLIR is the view up. Whenever the output size arguments are based on shapes of other tensors rather than the input tensor, it's really difficult to reason about whether we're expanding a dimension or leaving it alone, and so on. And so if you have that information of like, oh yeah, this shape here is from this tensor, which is the same shape as the input tensor, you can actually do cleverer things and not struggle as much.
That stuff is all in the FX graph. So yeah. I don't know if the right answer is that we extend the torch tensor type to include that, because it's not just symbol equality, it's symbol expressions. It's more of an affine expression.
Yeah.
That it preserves. So all that information is there. Either like we preserve it and use it, or we're currently just throwing it away.
Yeah. Yeah. I mean, this could also just be like an FX transformation, right? Where you just change the view arguments into like the right thing.
That'd be really nice to have. Any FX pre-processing that simplifies the situation would be great.
Yeah. Cool. I don't know if other people have questions.
So no, just on that point about throwing it away, I think I agree still it would be good to have the information kept somewhere, and yeah, whether we can model it in the tensor representation, it seems kind of the right place to have it somehow.
Yeah.
Because it enables so much of the important semantics for the compiler further on without them having to know the exact semantics of what the operation does, so long as they know how they relate to each other.
Yeah. I mean, we're clearly not doing the right thing by throwing it away.
Yeah.
And Dynamo doesn't enforce as well. Like if you improperly constrain one of these things, it'll literally throw you an error that says, I think I've deduced that your max sequence size is blah. You should include this constraint. And
oh, nice.
It's given me back like pages of like, you've given me 64 unrelated things that I think are related this way. Copy and paste this code. So it's definitely producing information that should help compilers. We should keep it and see how that goes.
All right, any more questions? Cool. Well, thank you, Stella, so much for the presentation. This was really informative. And I'm really looking forward to what comes next with Shark-Turbine.
Yeah, I mean, feel free to pull on us too. I mean, we're kind of dashing towards the finish line on some of these models and capabilities and whatnot. But if there's things that upstreaming or getting this more common or working on the project organization stuff would help, please pull. There's nothing sacred here.
Sounds good. Yeah. Cool. Now we'll have our usual monthly Torch-MLIR checkup, which never has any complaints from people, but maybe this month is different. So if you do experience any PR issues like slow reviews or debugging issues, or things are confusing in Torch-MLIR, this would be a good time to raise those questions. Also, you can just open a GitHub issue as well for this. But yeah, I'll open it to anyone who has any comments on this. Cool. We continue our streak. Well, yeah, thank you so much, everyone, for coming to the community meeting. If you have any more questions, discussion topics, feel free to ask now. But yeah, we're pretty much done.
Yeah, thanks everyone.
Thank you.
Very useful. Bye.
All right, I'll stop the recording.